Hello everyone, welcome. Welcome to the reInvent session, the next frontier in financial systems, transformer-based foundation models. Before I get started, would like to do a quick audience poll. How many of you ever had experienced your card being declined or getting a message from your bank that this might be fraud? Wow, yeah, we do have a couple of raised hands. If you all wondered, this is coming from the AI model that understands your credit card history. Today, what we're going to do is we're going to learn about newest foundation model and how it is transforming the financial industry and how NVIDIA is accelerating the innovation. So my name is Sudhir Kaldindi. I'm a principal solution architect working with AWS. I do have the pleasure of joining the stage with Pahal, and I'll let Pahal introduce.
Hello everyone, my name is Pahal Patangia. I lead NVIDIA's global business for the payments industry. I've been with NVIDIA for the past 4.5 years and continue to grow the adoption of AI and accelerated computing within the broader payments ecosystem and our customers and partners. Looking forward to presenting today.
Thank you, Pahal. So in today's agenda, what we're going to do is we're going to cover about why transformer payments, and then we're going to look at how foundation models is using transaction data, which is happening patterns at scale. And then we're going to see how it is unlocking personalization and also the pattern mining. Then we're going to see how we're going to deploy or develop on AWS solutions using NVIDIA acceleration. And finally, the key takeaways and the call to action, how to get started and how to get deployed on AWS environments. So that being said, if you look into it, right, why payments need a new class of AI together? The world of digital transactions has exploded both in volume and complexity. Billions of transactions is flowing through these massive systems every day. So whether it is credit card transactions, QR, or it could be contactless, or it could be cross-border payments, right? All we see is they do generate vast, massive, diverse data sets. And these data sets, again, if you see right in your organization, you might be using rules-based or an AI-based model that may not even to resolve. On top of it, the frauds are also becoming increasingly complex, meaning today they use chatbots, they use, again, what we see is generative AI to simulate synthetic identities. So what we need to do is we need to see the payment transactions are happening in real time and also curbing the fraud. So what we are going to learn about is the newest level of foundation model, which is transformer-based foundation model, and how NVIDIA is accelerating. And Pahal is going to talk about the next set. Why transformer payments?
Thanks, Sudhir. So if we think about the world of financial services, the world of banking, the world of payments, it is largely an arena where there is a lot of structured data. There's a lot of tabular style data, relational style databases, and that's where the ton of information for the industry has been stored. And so far, the world has always relied on the structured data and combined it with some kind of algorithms, be it statistical or machine learning based, to extract insights or make a prediction or ultimately derive more value towards it. And that is where we have seen the opportunity that if we up the ante on the algorithms is where we would be able to extract that additional delta of insights, additional delta of prediction. And that is where we are seeing the world of transformers being very crucial in changing that trajectory. And that is rightfully so, because at the end of the day, all financial institutions are vying to grab a piece of that personalized story of a customer. They want to know where the customer is spending versus they want to know what the risk profile is and how do all these things tie together so that they can give the customer the next best offer, or they can predict what the next transaction of that customer be. And that context building is something which is very well encapsulated by the likes of algorithms, which are transformers. And that's been the juncture of where we are in terms of using the technology which is fueling the generative AI and the unstructured data processes around it, but also combining it into the world of structured data and taking it to the next level. So why they are powerful? The key reason is that transformers are able to capture not just the static features of a customer, but also the dynamic trends. So what have been my likings throughout in the past 5 to 10 years of my history versus what are my recent interests? how do you capture both the information together? Until date, there have been algorithms, there have been methods, but more and more effectiveness has been seen with the likes of transformers, and that's the ultimate pull which transformers bring for the broader industry. And at the same time, if you think about how we have been doing predictive models in the broader industry, this is how a typical pipeline would look like. You have your tabular style data sets, and you would point them to a machine learning algorithm, a target variable, a predictor, and ultimately you are predicting probabilities. And this has been done very well. The likes of XGBoost, the likes of LightGBM have always found greater flexibility and greater accuracy and efficiency when it comes to pointing these algorithms at the data. But now is the time where we are seeing this pipeline, which you see the canonical pipeline at the top, could be augmented with the likes of better algorithms, and that has given birth to the rise of what we call sequential models into the financial services domain. And these sequential models are not new, but have been around for a while. Talking about pre-transformer era, pre-2017, the likes of RNNs, the likes of LSTMs have majorly dominated financial services firms, because there's a lot of data which is not just structured, but also, say, in a time series fashion. There's a certain sequence to it, there's a certain temporal pattern to it, and that is where these sequence models have found value in one way or the other. And they were, for a lot of time, kind of a notch up than the traditional machine learning algorithms. And what the industry and what the community was kind of grappling with them was problems like vanishing gradient problems, or in other words, you're not able to capture context for a longer window. And those were the pressing points, if you will, which let the industry, let the researchers think how can they leverage new algorithms, and this gradual shift gave rise to the emergence of transformers into this domain. And the other pieces, as I mentioned earlier, how do you capture temporal aspects of a customer's behavior or a sequence of transactions, both from a recent view and an old view? And then how do you connect it with different entities? What are the connections it has with respect to your friends, your network, the kind of places you're shopping at, etc.? All of those could be more intricately captured by the likes of these sequence models. And this is the augmentation which I was talking about to the pipeline. So we have seen the world where traditional machine learning has found enough value. XGBoost is all we need. The paper resonates with a lot of people. So do I. But where we are seeing more and more push into the new domain is the idea of embeddings. When you financial services is an industry which requires explainability to be at the forefront. There needs to be a certain level of transparency in the way decisions are made and in the way these algorithms are used. So you can't take a frontier model and just put it in the front of your data and let it do the predictions. It'll be a black box model. If you take that to a regulator, the regulator will shoot you down, and there'll be penalties and so on. What could be done, which is a middle way, that you could leverage the technology and the innovation that is happening, but also you satiate the regulatory requirements from an explainability and a governance perspective, is that you let the likes of tree-based models be at the frontier of your decision making, and at the same time you augment your features with embeddings which are built out of transformers. These embeddings would ultimately augment and aid to the predictive accuracy and power, which was not present in the vanilla tree-based models which you are doing. So embeddings as features, when being fed to these end models for prediction, would ultimately yield that higher level of accuracy or lower level of false positives, whatever you are optimizing for. So these started with a very good premise on fraud as an industry which is proliferating, and ultimately it's AI's job to curb it. And the way we are seeing more and more work being done in the industry is the emergence of these embeddings, which help inform what are the entity connections, cluster your transactions together, and understand patterns more effectively than just looking at a row by row fashion. And that's the power of embeddings, which is just an additive step in parallel to the traditional machine learning workflow which we have been seeing. And in that spirit is where the value of transformers being exposed. So the moment you expose transformers to large amount of data and make it learn patterns, it's a large data problem, it's a large compute problem. And the way to parallelize those operations, when your transformer models are learning the patterns in your data, not just your entity level data, but different modalities of data. And when I say modalities, I don't mean text, videos, images, but different flavors of data, be it the merchant data, be it the bank data, be it the different event logs from a click-through perspective, etc. How do you blend all these worlds together and expose that to the transformer architecture? That problem is massively compute heavy. And that is where parallelization becomes key. And that is where GPUs in general become very effective in parallelizing those operations when you are training those embeddings, when you are fine-tuning models to cater those vanilla models to particularly your data. And that is where what we have done is we have built certain libraries, certain toolkits, which are available as open source, which are available on AWS's managed services, be it SageMaker, be it the marketplace, etc., for developers to ultimately take value in terms of, say, fine-tuning, in terms of converging their distributed pipelines, etc. So what we have seen is, what we are seeing is a transition of the industry going from the traditional rules-based methods to more deep learning-based methods. And this transition has been very gradual over the years. The earlier years in the industry were very much focused on heuristic rules, which were so static that they were like a reactive approach. That an incident would happen, and then the institution would apply those rules, and then fraudsters would find new value around it, new ways to get through those rules. And that's where the machine learning algorithms found value. And now, more and more, we are seeing moving from those machine learning algorithms and aiding them with these embeddings, both from a transformer architecture perspective and also graph neural network perspective. Depending on how you want to structure your data, these embeddings continue to become the foundational layers for these new kind of models. And that is where you would see a lot of learnings which we have been seeing from our customers and partners being involved into how can they shape their data. Now, a traditional approach for training these foundation models on tabular and structured data has been around, you could take an open source model which is trained on language, like a llama or a Quen, like a model, and then you fine-tune that model basis your tabular and structured data. Now, these models by nature are attuned to cater to text and unstructured data. But when you have the ability to fine tune them to speak the language of the domain, in this case, say payments, they become highly effective. They become the tools to predict what could be the next transaction, or they also could become the tools to encapsulate all the behavioral patterns from a customer. And these learnings come from largely two worlds, come from the world of large language models, as we are seeing more and more progress in the domain, as well as graph neural networks. That how do you leverage these embeddings together to ultimately feed it into these frontier models. And that is where AWS and NVIDIA have built like a fraud detection blueprint, which you could leverage, which you could think of as GNNs as a service, where you could expose your data and build GNN embeddings out of it, and ultimately feed them into the models which you are using for prediction. And to take those learnings and feed it into a pipeline which is like a tabular transformer model training pipeline. I think the very big key step, as we talked about, is making that language model learn the language of structured data. And how do you make sure that it understands the patterns and nuances which are stored in cells and not words and sentences? The key part of doing that is writing your own tokenizers. There could be as simple ways as just making your transaction in a sentence, like Pahal did a $5 transaction at in and out on certain date at certain time, and he has been doing it for once every week, for example. That is a very simple and rudimentary form of tokenization. Here, there are different approaches which we have seen from the industry and the academia and research communities. So as to how do they take the tabular data and ultimately allocate, say, certain tokens for a particular cell and make it a fixated approach. On the other hand, you could also think about how do you take those merchant categories and tokenize for the most prominent categories, ultimately like a one-hot encoding structure. And like these are the techniques which have been more and more prevalent. So writing your own custom tokenizers has been the difference in finding accuracy with these models as compared to a vanilla large language model being exposed. There are two approaches which the industry has taken when it comes to pre-training these models. You could pre-train an entire model from scratch on your tabular data, write your custom tokenizers, build your own structure and architecture, and ultimately take it at scale. That's less prevalent. The number two method is take an open source model, which could most likely be a language model, and then fine-tune that open source model to ultimately cater to the domain of the data you have. And that is the method which is more and more coming up to speed and fashion. And the way you represent your tokenizers and your data in cells is becoming more and more important. And that is where the techniques which we used, the techniques which we talked about, continue to come into fashion. It's about breaking those key important fields into what matters when it comes to a transaction. What kind of amounts are those versus how do you break a date into a month or day or a day of week, and then extract more valuable information out of it, and ultimately how do you handle that long tail of merchants, merchant names which are not so popular. These are some of the considerations which we are seeing being done, and all of these problems are hard problems when it comes to computation time and the accuracy of these tokenizers. And that is where some of the libraries from NVIDIA, like NVIDIA Rapids, which goes very well into the likes of SageMaker, come into play and help developers build these tokenizers at scale. And then as you build your tokenizers, it's about fine-tuning your models and ultimately helping them learn the language of your data. And this is where we draw the learnings exactly from how we fine-tune large language models of today into taking all those steps, but now applying into these new tokenized bits of data coming in from these tabular data. And the kind of steps remain the same, the fine-tuning methods remain the same, and the kind of frameworks and libraries that go along also remain the same. At NVIDIA, we have a framework called NEMO framework, which is like an end-to-end framework for customizing and fine-tuning your models, open source models, and ultimately making sure that your models converge effectively, that your training runs in a distributed fashion are running in the most efficient way, and at the same time, if you want to up the ante with techniques like reinforcement learning for human feedback or supervised fine-tuning, you could do those techniques as well. And that is all encompassed as part of this workflow. So this is how the ecosystem and the community is thinking about leveraging these payment foundation models or foundation models on tabular data. This space is super early, but we have been seeing more and more transcendence into new use cases that would emerge as a part of this effort. And Sudhir would talk further about it.
Yeah, thank you, Pahal. So here, right, if you think about it, every customer interaction, whether it's a swipe or even a tap or even a transfer, right, that all forms a kind of a sequence. As Pahal has already articulated what a sequence is. So, and that sequence tells a story about the customer behavior, right, their habits, their intent, and their purchase. So on the left-hand side, as you could see, there is so much financial data coming in. We have transactions, account information, and we do have digital behavior and banking. All this provide various signals for a particular company. So what we need to do is, and we need to build a foundation model, as you could see in the center, right? It tries to build the relationships between this data. And how this tries to build the relationship is because it has to understand the context and also the payment criteria. And just like a transformer, right, as a plain English language, it understands sentences, and then each sentence is like a word of tokens. Similarly, for the payment transaction, what you see is it's more of a payment history as a sequence, and every transaction happens to be a token. And this particular sequence gets trained across millions and millions of transactions. On the right-hand side, as you could see, once you build this foundation model, then you could able to personalize for your fraud detection, AML, product recommendations, and even transaction monitoring. And once you build this can be built on NVIDIA because they are superior in accelerated computing, and that can be scaled across millions and millions of transactions. So now let's look into how foundation models extend beyond fraud detection. As you see in the diagram on the left-hand side, you do have raw data coming in. The first step what you need to do is you need to structurize. So that is where you have transactions, and you do have user profiles and merchant profiles. And once you structure the data, the next step is all about enrichment. And here we could able to use NVIDIA Rapids, which can be run on Spark. And that NVIDIA Rapids can do the feature engineering, which can does filtering, sorting, aggregation. But what we have seen is it needs an expert intuition. So the next step is all about what we have seen customers is they are using RNNs, which are nothing but recurrent neural networks. But again, they do struggle with long histories and also large time behavior patterns. So the next step what we are seeing is where NVIDIA is working on transformer and GNNs. What the transformer does is it tries to learn from the history of your payment history, and GNNs, it tries to understand the relationships between users, merchants, and transaction data. So once you build this can be deployed on AWS solutions, and again using NVIDIA NEMO and PyG and DGL, this is especially for GNNs. Once you build this transformer in GNNs like a tabular foundation model, this can be fed into your training, but what it does is it was creating an embeddings, And these embeddings can be fed into your downstream model. In case of fraud detection, where most of the customers use XGBoost, and here you could able to leverage NVIDIA XGBoost on Rapids. Once you have this training part done and you have the model deployed, then that is where you're going to do the prediction part. And here you could able to leverage NVIDIA Triton, and this can able to scale to millions and even billions of events in real time. And again, if you see at the bottom part of the use cases, right, this can be fed into personalization, and again for especially where you have authorization and routing, and also for dispute protection. Again, you are not stopping it here because the fraud keeps evolving, and you do get a lot of fraud vectors coming in, and you take this fraud vectors, retrain, and this continuous life cycle continues. So this is at a high level of how the domain level logic of how you build transformer based foundation model. So in the next slide, we're going to see how you're going to put into action. So as you see, right, like you do get a lot of data coming in, which could be your third parties, SaaS events, and your operational data, right? And where you could able to leverage a lot of AWS services, again, Airflow, Kinesis Data Firehouse, you have Lambdas, and you have Amazon Athena. Once you have all the data coming in, this is like your ingestion state. And the next step is where you need to structure this data. And here where you could able to leverage NVIDIA's Rapids, where you could able to structurize the data. And again, here you could use batch transform, especially for offline GPUs. And you can also use FSX for Lustre. This is for high process storage for your massive data sets moving into the training part. So in the middle part, what you have is more of your tokenization part, where you're using NVIDIA NeMo framework, where you could able to tokenize your raw transaction data into more of a sequence based. Once you do that, this is the important part. This is where we are training it. And in the training here, we could be able to leverage SageMaker. On the SageMaker, where you can have NVIDIA NeMo framework with running on PyTorch on the SageMaker Hyperpod. So once you have that, then the next step is if you wanted to have relationships, that is where you could able to use GNNs. And here you can also leverage PyG and also DGL framework, where you can have the relationship between the graphs. Once you build this tabular foundation model, you would be getting the rich embeddings, which would be giving you a dense behavior of the customer. And this again, where you can input into Amazon vector database, where again this embeddings, right, again if you really wanted to see, if I wanted to find a similarity search between customers, that is where vector search would help you. Once you have this vector search, there is an ML flow where you could able to train and intelligently would identify the best model, and that best model can be used for your training. And here again, as I said, an inference layer Triton can be used for your billions and billions of transactions. And once you do this, this can be done for any kind of a downstream model. So rather than you building unique model for each and every use case, here you are trying to build an aggregated model that can be used as a universal financial behavior for your entire organization. Sorry. Now let's look into how we could able to operationalize this ML workflow. On the left hand side, as you could see, you have the SageMaker Data Wrangler and SageMaker Processing Job, which could be used for cleaning, transform, and feeding into the raw data. Once you have it, you're going to push it into the feature store, and this feature store is going to give you an inference and also for your training purposes for all the features. And the next step is all about training and tuning. In the training and tuning, what we see the data scientists or even the data engineers, right? They try to do multiple SageMaker AI experiments, and once you identify the best model for your particular need, that can be pushed into your model registry. And once your data scientist or lead data scientist approves it, that would be used for your deployment stage. Here in the SageMaker deployment, where you can run multiple target experiments and you can deploy as a target runtime for your endpoint. And as you could see, this can keep evolving. And once you see like a lot of model vectors coming in, that can be again input back into your SageMaker experiment, and you can train, tune, and finally deploy. And let's see how do you convert into this SageMaker LLM pipeline in AWS. As the left hand side, as I said, yes, the data scientists, they would be getting the raw data coming from your different streams. And here where you're going to build SageMaker experiment, pre-processing, building the notebooks, training scripts and everything at the second step. And third step is, that is where you're going to build SageMaker pipeline, where you do the model evaluation, transformation, and then registry and also deployments. Once you build the pipeline, then you're going to commit the code. The code would be again, whichever resource repository you would like to. That is where it would be triggering a code pipeline. And the code pipeline in turn would be generating a SageMaker pipeline, which where it would be deploying the model endpoint, the model. So once you have the model deployed, normally what happens is it goes to the model registry, and in the model registry, that is where it goes to the lead data scientist. Once they think this model is good enough, that is where they push it into the pre-prod stage. In the pre-prod stage, again, you would be training against with your production data or even the pre-prod data environment to see how this model behaves. And that particular, once that's been approved, it goes to the next stage, and on the final approval, that is where you would be launching in the production state. And as and when you see a lot of transactions coming in, you would be retraining and the whole flow continues. So this is at the high end, how you could able to build, train, deploy using a SageMaker pipelines automatically using the tabular foundation model. Now again, in the financial industry, right, we always talks about security. Security is definitely number one criteria. And on the top, you do have AWS managed services where you have Amazon Inspector, especially for vulnerability scanning, and you have AWS config for configuration governance, and CloudTrail for all the cloud activity, what you could see. And we do have services like AI, SageMaker AI, Bedrock, and you have ECR and also A2I. This is for building and experimenting and training your AI model securely. And in the bottom part of the stack, what you have is self-management, where you have AWS KMS for key management, and you have identity access management for identity controls, and you do have VPC, that is for separate network segmentation, and WAF for again threat isolation. We also work with the third-party solutions, and here we use Splunk, Qualys, CrowdStrike Falcon, Prisma Cloud, and Okta Identity Management. Again, this is for cloud security posture and also for endpoint protection, and again for identity management. Using all these services where we can help you build a state-of-art secure financial tabular solution model running on AWS, partnering with NVIDIA. So in the next slide, Pahal is going to talk about the early success and key takeaways.
So these, as I mentioned earlier, these efforts have been industry-wide, have been prevalent. I think one of the most marquee examples is from a payment fintech who trained their payment foundation model to detect card testing attacks, and their accuracy moved from 58% to 97%. Another large LATAM neobank has been training their payment foundation models and and what they are doing is they're building like one size fits all model, which speaks to these different use cases and cater them accordingly, be it fraud, be it personalization, be it dispute prediction, etc. And they are seeing an increment of AOC by 2%. Again, there are no business outcomes associated with it yet because this is too early stage, but that's where the ecosystem is headed. We recently had a large payment network release a paper on transaction GPT. It's basically talking about the same things and how they're seeing value bringing transformer models to tabular data. And ultimately, another large bank presented at NVIDIA GTC on building recommender systems out of transformers. We have a library called Transformers for Rec, which again uses the same principles as the concepts we discussed today, and they see 10 to 12% increase in engagement. So, like really great examples and stories coming from all over the ecosystem, and that's where every enterprise and every company is experimenting with it. And as we think about the session today, I think the one big thing you should take away is that we, being NVIDIA or AWS, are not building these foundation models by ourselves. What we are rather doing is we are enabling you all, you developers and the enterprises and our partners, to ultimately help build them effectively for your use case, for your own end data and your own end solution. And we have the right tools and the libraries, some of which were name dropped in these conversations. Definitely have a greater look at them and see how you could leverage those tools and capabilities to the best of your use. Ultimately, the idea is when we talk to customers, the biggest problems are models are not converging, accuracy is low, machine utilization is not enough, costs are high. How do I justify it to go from a POC scale to a production scale? All those things being catered, these architectures, these reference blueprints are the recipes for you to take that step and remove these barriers, if you will. Now, and in the pursuit of that is where you would see the two platforms coming in, both from a performance perspective as well as scalability and trust, is where AWS and NVIDIA have been majorly partnering together. And ultimately, what we are seeing, and we'll continue to see more and more, that the industry would be able to harness transformers by pointing it to both transactional tabular style data and also unstructured data and combining the two worlds together. So our hunch is that there'll be more one-size-fits-all models coming in, which will again dwarf into small specific niche models. But those global embeddings would ultimately help build that greater context about a customer, about a product, about an offering, an entity, etc. That's where we see the puck going. So if you are experimenting and building along, definitely get in touch with us, and we'll be happy to help. We have our solution architects, we have our engineering leaders, we have our partner ecosystem to come and help you, because all these best practices are being imbibed into our greater ecosystem and channel as well. And that is why we would invite you that if you are on the journey to augment your pipelines from traditional machine learning to the likes of GNNs and transformers, this is our chance to talk. So please do reach out. Have a really good reInvent. If you want to, if you want to connect with us, both of us are available on LinkedIn. And at the same time, we'll be happy to take any questions off the stage as we conclude the presentation. Thank you so much for your time. Thanks, Sudhir.